So in the second iteration, see, you cannot stop because you are getting negative values. So unless and until you get all solution values as positive, you cannot stop the iteration. Okay, so here in the next step, you have to see the key column. This row is obtained by dividing the key element. That is, this you get it as -2 divided by -2, you get 1. Then 1 divided by -2, you get -half. -1 divided by -2, you get half. Okay, in the same way you get this first row. Okay, you have to just divide -2, that is key element, by that earlier row. And this one also, solution, -4 divided by -2, you get 2. Okay, then to find row 5 and row 6, so you better note down this one, row 4, row 5 and row 6, and this one as row 1, row 2 and row 3. Okay, and again you have to apply, see, in order to find row 5 and row 6, you have to apply the formula, and this same formula is applied. Okay, in the last session, in the last video, while solving this dual simplex problem, we had used the same formula. Okay, this same formula is used here. If you can see here, if you want row 5 here, old value minus key column value into R4, that is the new row. So you get 1 minus 1 into 1, that is, old value was 1. You can see here, old value was 1, corresponding column value is 1 into new row, that is R4. What is the new value of R4? That is 1. So 1 minus 1 into 1, you get 0. Okay, next one, the old value was 1, the corresponding key column value is 1 into R4. So what is the R4 value here? It is -half. So 1 minus 1 into -half, you get 3 by 2. So similarly, all the values are found using the same formula, even the solution. So solution, it will be, older value was 8, sorry, yeah, older value was 8 here. Now corresponding key column is 1 into the new value is 2. So 8 minus 1 into 2, you get 8 minus 2, that is 6. Okay, so in this way row 5 is found. And similar same step is followed in order to find out row 6. Okay, and see, you get row 6 here. Okay, these are the values. Now if you can see here, you get values as 2, 6 and -2. So again you are getting a negative value, which means again you have to do the you have to go for the fourth iteration. Now this and from these three you have to choose the least more negative. So here it is very simple, that is -2. It is directly found that -2 is negative, so this will be the key row. Now again, to find out the key column, you have to use the same formula, and also you have to find Zj and Cj minus Zj values. Okay, in order to find out the key column, you have to first find out Zj and Cj minus Zj values. Okay, now so again the same formula is used, that is minus of Cj minus Zj. You write all the Cj minus Zj formula, that to minus. Okay, it should you have to write it in the negative form, and S3 values. Okay, S3, see, in the last iteration you had taken S1 values. Okay, but now you have to take the key row. Okay, so last time the key row was S1, but now it is S3. So you have to take values of S3, that is 0, -1, 1, 0, 0, 1. Okay, so here 0, -1, 1, 0, 0 and 1. Now again, see here, 0 ratio, you have to find the ratio. 0 divided by 0, so denominator is 0, so you just neglect the value. Next, -5 by 2 divided by -1. Here the condition is correct. There is a negative number in the denominator, so you can consider it. But here if you see -5 by 2 divided by 1, again it is a positive value in the denominator, so you just neglect it. Next, divide by 0, so 0 in the denominator, so again neglect. Here again 0 in the denominator, so neglect. Here again a positive number in the denominator, so just neglect it. Okay, so you get only value, that is 5 by 2, so that will be your key column, that is x by 2, sorry, x2. So here x2 is the key column and -1 is the pivot element or key element. So again you cannot stop this iteration because you are getting a negative value, so you have to go for iteration 3. So here again CBA, you write all the things here. Then you have to change the S3. that is you have to divide this row by key element, that is -1, and you get these values. Okay, you get 0, 1, -1, 0, 0 and -1. And for this also you have to apply the same formula that is here, to find new element, old value minus key column value into R9. If you can see here, you have to always multiply with the row 9. Okay, row 9 in the sense whichever the key element or the key row you get, with that row you have to multiply. See, in the, for example, in the last iteration you had multiplied it with R4, that is by after dividing the whole row or the key row by key element, you are getting a new row, that is row 4. So you divided that, you multiplied that value. But here you have to take row 9 because your key row was row 6. Okay, and after finding, dividing -1, you get this new row, that is row 9. So you have to multiply row 9. So don't get confused here between the like which row to be multiplied. Okay, so then 7 and 8 you find using this formula. Okay, and you get, see, after getting, you get values here, and here x1 will be replaced. Okay, and x2 will be, as I've told you, x2 will be the entering variable, and you have to write the values. Okay, 1 and 2. Next, see, here you get 3, 3 and 2. See, if you can see, you get all positive values. Okay, so this is the end of your iteration. When you get all positive values, it means that it has reached to the basic feasible solution. So you have to stop it and just multiply. Okay, you find the zj value here. Okay, by multiplying it, 1 into 3 plus 0 into 3 plus 2 into 2, you get it as 7. Okay, see, if this is your answer, okay, z value, but we will just verify it whether it is correct or no. See here, x1 value you got it as 3, x2 value as 2, and x3 as 0. Okay, 3, 2 and 0, you can see here. So now z equal to 7. So here minimum z equal to, just substitute those values in the objective functions, that is x1 plus 2x2 plus 3x3. x1 plus 2, the x2 value is 2, then x3 value is 0. So you 3 plus 4 plus 0, you get z equal to 7. So this is the feasible solution. So by this you get to know whether your answer is correct or no. Okay, so this is how you solve this dual simplex method by without converting this minimization into maximization, and using this particular finding this this method. Okay, to find entering variable, you use this method, that is positive in the denominator and positive 0 in the denominator. So this is another way you can solve any method. Okay, so if it is a maximization problem, you can just keep it as a maximization only, and you can change the constraint values and solve by any method, the earlier method or this method. And if it is minimum, you can just solve by this method, or you can convert it into maximization and solve it. So this is about dual simplex method, and it's a very important question which is asked for 8 to 12 marks. If there are 3 or 4 iterations, then they ask it for 12 marks. If there are only 1 or 2 iterations, then they ask it for 8 marks. Okay, so very important problem.